goodness to man question. How can prove it? Knowing this about electricity, Franklin asks himself one more question. How can this knowledge serve humanity? It has pleased God in his goodness to mankind to finally show them a way of protecting their buildings from the mischief of thunder and lightning. Take a small iron rod with one end buried 3 feet. In his almanac of 1753, Franklin reveals the details of his invention. A rod of iron placed on the roof of a building can safely discharge a bolt of lightning down a wire connected into the ground. He doesn't patent the lightning rod. It will be his gift to the world.
The ordinary lightning rod, the Franklin rod, is still the basis of the lightning protection code in every single country in the world. It's still today the best way to protect an ordinary house or a structure from lightning damage.
Calming the ogre of lightning, this frightening thing, has had a huge impact on public imagination. There was an episode, for example, of 2 ships side by side. One had a lightning rod, one didn't. Both struck by lightning, one destroyed completely. The one with lightning rod, perfectly fine. First, the clergy felt that he was usurping a prerogative of the Almighty. Franklin said, well, we do not hesitate to protect ourselves from the hail of heaven with roofs and shields, so we should be entitled to do the same with lightning.
In an age of reason, his proof that the lightning discharge is an ordinary natural phenomenon and not a manifestation of the powers of darkness or the force of an angry God was seen as a tremendous blow for reason against superstition.
In 1753, Franklin is awarded the Copley Medal, the 18th century equivalent of the Nobel Prize for Science. This once runaway printer's apprentice is now the most famous American in the world.
Okay, guys, the lightning rod, which is made up of metal, right? Does metal attract lightning? Yes or no? Is that the reason it's made up of metal? Alright, so this was the question that we had in the beginning of the lecture, so that's what we're investigating. Does metal attract lightning?
Here, Dr. Jeff McHarg is using a super slow motion camera to capture lightning.
Okay, so we have already seen this one.
We call it.
Alright, moving forward. Does metal attract lightning? Alright, you got the lightning rods on top. Alright, so the lightning is missing the Chicago Tower. Alright, look at these pictures. What do you suppose the size of these lightning bolts are? When you guys are looking at, do you think this stuff is really thin? Alright, I'm talking about the diameter or the radius of this thing. Given the fact that you can actually see this miles apart. This picture, the distance between these 2 buildings, I used to work here. So this is about a mile, and this distance is probably about 10 miles, and look at the size of this. Alright, so what do you suppose the size of these bolts are? Lightning bolts are. Alright, so we can get a pretty good estimate of that. So let's use the problem number 4 for lightning. So we're going to be looking at the visible portion of the lightning strike. Alright, so what do we have? We got the linear charge density for this. Alright, it's going to be 10 to the minus 3 coulombs per meter. So it's given to us in terms of a linear charge density. And, oh, I hate this one. Once again, they claim that the air molecules break down, which means that they will just ionize, and an electric field exceeding 3 million newtons per coulomb. If that's the case, guys, the lightning would just light up the entire surface of the Earth. That sort of stuff is crazy. Which means that the entire air would become ionized. Alright, so let's go with the assumptions that I'm seeing here. So the electric field strength is going to be 3 million, and the linear density is going to be 10 to the minus 3 coulombs per meter. So the question is this. You got the ground. So the lightning is going to strike. And we will be taking a look at a small portion of it. You're going to grab a region like this. Just copy it out. And what I'm interested in is the radius of that region. So what I'm going to do, I'm going to make a small circle, which is located right here. And then I'm interested in the radius of that small region. Okay, so I'm declaring it. That's what I need. Alright, so what's given to us for that region? So R is what we're trying to figure out. Question mark in terms of meters. And maybe express it in terms of feet. I mean, it looks like it could be in terms of inches, but we got it. Or else you would not be able to see that from that distance away. From that far away. Alright, so linear charge density is given. It's going to be 1,000 coulomb per, what is it, meter? And also the supposed strength of the electric field is given, so this is going to be 3 million. Newtons per coulomb. Alright, so what is the size of a lightning bolt? What's the thickness of it? That's what we're looking at. What's the radius of the cross-sectional area? The best way to do it is just turn this region into a Gaussian region. So in green that you're looking at, this is going to be my Gaussian. Okay, so I created my artificial Gaussian region. Now everything is in green. And then now I should be able to solve this problem just fine. Okay, so I listed everything that we need. And then let's move forward. There's going to be a net charge here. Alright, so within that Gaussian region, the flux of the Gaussian region is going to depend on the strength of the electric field intercepted by the area of the Gaussian. It depends on the net charge on the inside. Alright, so here's our generic expression. Alright, so we will be looking at the electric field coming out sideways, which means that the area is going to be also parallel to it. So I'm going to rewrite this. Alright, so this area that we're looking at is a cylinder. Alright, because it is a cylinder, we know that the area of a cylinder is going to be the circumference times the height of the length that we're looking at. Alright, we're only interested in the area of the Gaussian, which is going to intercept the electric field, so that's going to be the area which is the underside that you're looking at. Alright, so we'll do a back substitution, meaning that this is going to get substituted back into this. The strength of the electric field is assumed constant, so it's taken out outside of the integral. So we got 2 pi RL divided times E, net charge within the column itself, divided by epsilon naught. Alright, solve for R. Alright, so when you solve this for R, this is what you end up getting. You have 2 pi, I got my constants here. Right, I'm going to keep my constants here. 2 pi, and then you have E. You got your L, and you have your E. Alright, so at this point, I'm going to check to see what I have. Check to see if I'm done. Alright, so we got a value for E, which is good. So it's going to go here. And epsilon naught, this is a constant looking up. Pi is a constant looking up. Alright, do we have a value for Q? Oh, no, shit. Do we have a value for L? L would be the length of the column that you're looking at. I don't know what my Q is. I don't know what my L is. So what do we do?
Give up.
Alright, yeah, that's one way to do this sort of stuff. I mean, at some point, some of you guys will give up anyway, so that's the reason why I recommend that you guys take a lot of business courses. If you don't have what it takes to be an engineer or whatever, just get into business, guys. You can be a manager. Less talented ones tend to be the managers. Right, hopefully you recognize talent and keep the engineers around. Alright, so that's what happens. All the amazing engineering schools tend to have amazing business programs for that reason. Alright, so those of you guys who don't want to give up, I mean, shit, people. I mean, boom. We want this. It's not given. And we want L. L is not given. Instead, this is what they give us. Okay, what is this for?
Well, another formula.
We have, yeah, you use the formula for linear charge density.
Okay, which is? All right, so this formula that you guys, I like the way you guys go, oh, we got a formula, man. You guys are still thinking in terms of formulas. Think of in terms of concepts, which can be expressed in terms of formula. What is the linear charge density? It's the net charge along a line, right? All right, so this is the net charge along the column of this lightning bolt that you're looking at. So in essence, you got what you need. You don't have the individual values for this, but you have a collective value. So what that means is you got a value for this divided by that, right? All right, so we got that. So here's what we know. Since Q divided by L is the charge density. Okay, because of the fact that that's this divided by that is your charge density. Then we got everything we need. All right, so this is going to be lambda divided by 2 pi epsilon divided by E. Okay, now we got everything we need. All right, so we got a value for this. This is going to be 3 million. We got a value for this. This is going to be 10 to the minus 3 coulombs per meter. You plug your numbers in, and then you will get yourself a number. What is it, 20 feet or something? What is the radius? All right, So the entire region that you're looking at, the radius here is going to be about 20 feet. Probably remember that. I don't have the numbers. So, moving forward.
Overcoming
So metals, do they attract light?
the damaging effects of one lightning strike can be hard enough, but a few rare individuals, like Park Ranger Roy Sullivan, are proof that lightning can strike twice and more. His daughter remembers his first strike.
This is from the first one, 1942, and lightning went through his watch. And so it has a hole through side to side.
For 27 years after this first strike, Roy was untroubled by lightning until one fateful day in 1969. A side flash bounced into his truck, hitting him in the neck and burning his head.
So can you be struck by lightning while driving? Yes or no?
Yeah. Yes, your windows open.
With your windows, absolutely. Yeah. So roll up your windows, guys. Roll up your windows. More than likely, you're not going to take a direct hit. It's usually a side flash. Side flash is usually survivable, obviously. All right. So
By lightning
just roll up the windows so the streamers from your body is not connected to separators from the car.
until one fateful day in 1969. A side flash bounced into his truck, hitting him in the neck and burning his head. The odds against Roy being struck a third time were over 1,000,000,000 to 1. But only a year later, near his home, lightning hit a transformer and arced to his left shoulder. But this was not the end. In 1972, while taking refuge from a storm inside a mountain station, Roy Sullivan was singled out for a fourth time.
I recall Roy having lost all of his hair on his head. He also had a burn around his ankle that was, I would consider, substantial.
Come on, Rick. How are you, Roy? Pretty good. Working a lot today? Sure am. Have a good one, too.
By 1973, Roy had taken to carrying a bucket of water with him when he made his rounds, in case he caught fire again. Even though he tried outrunning the thunderstorms, in June 1976, Roy was struck again for a record sixth time. And his troubles weren't over yet. The following year, while out fishing, Roy was struck for the seventh time, and he became known as the human lightning rod.
How many of you guys seen the movie The Curious Case of Benjamin Button? And those of you guys who have, remember the guy in the movie always kept talking about getting struck by lightning, and every time he would talk about it, the story was completely different. And he got struck 7 times in the movie, so it's loosely based on this guy's life.
People called him that before, human lightning conductor, but I don't know. I don't know if it was a chemical in his body, but he said that before.
Roy was worried that metal on his body might be attracting the lightning.
He didn't even wear a wedding ring or watch because of that. He didn't wear those.
Belt buckles and metal zips fuse and melt after a lightning strike, and many lightning survivors have terrible burns for metal objects that they were holding or wearing. But does metal on the body actually attract lightning?
So does metal on the body actually attract